Hello students, in this video we are going to continue limits. Already in 2 videos we did lot of questions, we studied special limits, right? In this video I am not going to give anything new. So what we studied in the previous two videos, based on that we are going to do few more questions, okay? Now let's move on to question number 23. Limit x tends to 0, root of 1 plus sin x by root of 1 minus sin x by tan x. First, directly you substitute and check it. First, when you put x equals 0, sin 0 is 0. So root 1 is 1 minus again 1, so 0. Tan 0 is 0. So it is 0 by 0 form, indeterminate. So in this question, hope you can understand the method, right? Whenever root comes, we multiply numerator and denominator by the conjugate. So whether it is the numerator or denominator. So limit x tends to 0. So what do you have here? Root of 1 plus sin x minus root of 1 minus sin x divided by tan x. Divided by tan x. This is what we have. You multiply by root of 1 minus sin x plus root of 1 minus sin x. So now you see the numerator, that is of the type a plus b into a minus b. So you can write it as limit x tends to 0. A minus b into a plus b, a square minus b square, a square, the root cancel, you get 1 plus sin x minus b square, so minus of, right, put a bracket, 1 minus sin x divided by tan x can be written as sin x by cos x into root of 1 minus sin x plus root of 1 plus sin x, the first one, right? 1 plus sin x. So a square minus b square, yes. 1 plus sin x plus root 1 minus sin x. Now we simplify. So here limit x tends to 0. 1 plus sin x minus 1 minus minus plus sin x divided by sin x by cos x, it has to go up, next step we will do, into root of 1 plus sin x plus root of 1 minus sin x. Better this step you can avoid, this minus of, directly multiply by minus and you write, okay. So now plus 1 minus 1 cancel, so limit x tends to 0. Sin x plus sin x is what? 2 sin x. Denominator is we have a sin x by cos x, that goes, cos x goes up into root of 1 plus sin x plus root of 1 minus sin x. Again you cancel sin x. The sin x only given a lot of problem, right? Sin 0 is 0, but now all the sin get cancelled. So now apply the limit. For x you put 0. So 2 into cos 0 is 1 by root of, here sin 0 is 0, but root 1 is 1, right? Root 1 is, straight away you can write root 1 is 1 plus again root of 1, it is 1, because sin 0 is 0, root 1 is 1. So you are getting 2 into 1, 2 by 1 plus 1, 2, so your answer is 1. Okay, now let's move on to the next question, question number 24. Limit x tends to infinity. Limit x tends to infinity, the power is x. Limit x tends to infinity when the power is x. So this limit should come in your mind. In the first video I taught this type. Limit x tends to infinity. X plus 1 by x raised to x equal to e. Another result similar one. Limit x tends to 0. You are remembering that? Limit x tends to 0 means that x will come. These two change the position. That x comes in, 1 by x goes up, right? Again your answer is what? E. In that case limit x tends to 0. So be thorough with the results and all the concepts. If you are thorough, then you can do it. So by seeing this question, x tends to infinity, the power is x. So yes, x tends to infinity, power is x. But all these things you have to make, right? You have to bring all these things. We need a 1 plus 1 by something. Okay, please listen. So first what I'm going to do, limit x tends to infinity Power is x. Denominator is x square minus 4x plus 2. I want the same thing in the numerator, then a by a, it is 1, right? So I'm going to write x square minus 4x plus 2, but the numerator is something else, so we adjust. So if you added something extra, you subtract. If you remove something, you add it, okay? So actually what do you have, x square? Yes, no problem, x square here. Then we need minus 2x, but we have taken minus 4x. We have reduced 2 more, so add 2x. So that x problem solved, right? Then we need only plus 1, but we have written plus 2. So 1 extra we have taken, so remove that 1, right? Now it is correct only, no? Yes. Now take this as one group, this as another group. So split into 2, limit extends to infinity. Limit extends to infinity. This by this cancel 1. Plus 2x minus 1 by x square minus 4x plus 2 raised to x. So some more we got it. Limit extension already got it. Now that 1 you got it, right? This 1. Now we need 1 by x. So 1 you got it. But we want 1 by something. 1 by something. So that's the next step. So limit extends to infinity. Limit extends to infinity. 1 plus, you write 1 by, write the reciprocal, x square minus 4x plus 2 by 2x minus 1. Value not changed. Actually the 2x minus 1 has to go up, raised to x. But one more thing, these three must be same. Which three? Here x, here power is x, here also x, then only you can write e. But here we have something. Here we have something, but the same thing we need in all the places. So what we do here, we give a name for this, okay? So we take, let that x square minus 4x plus 2 by 2x minus 1, you take it as what? We give a name, we take it as say y. So this is 1 plus 1 by y. Then I want y tends to infinity, but here x tends to infinity. Let us see, suppose x tending to infinity, what happens here? What happens to y? Then limit x tends to infinity, this function. So limit x tends to infinity, I'm taking this as 1, x tends to infinity, y is equal to limit x tends to infinity. So this is y value. So whenever limit x tends to infinity comes, you take the highest power outside, right? Numerator you take x square outside, 1 minus 4 by x plus 2 by x square. Denominator you take x outside, you will get 2 minus 1 by x. So this 1x cancel. So when I put infinity, please listen carefully. 4 by infinity 0, 2 by infinity 0, so 1. Here 1 by infinity 0, only 2, 1 by 2. But here we have x. For x you put infinity. So infinity into 1 by 2, it is infinity only, right? Infinity 1 by 2, it is what? Infinity. So you are getting x tends to infinity means y also tending to infinity. Okay, so now here this problem solved. X tends to infinity, you can write y tends to infinity. So limit y tends to infinity, equation 1 become, actually we have limit x tends to infinity, so y tends to infinity, you can write as x tends to infinity, y also tends to infinity. 1 plus 1 by y, this part we taken as y, right? So 1 plus 1 by y. Now what else you have? Raised to x we have, raised to x we have. So but I want actually y, so you multiply by y and divide by y. Now you take this as a group, okay? Take it as a group. So what you can do here, limit, okay, for this part you can write it as the power you multiply by y and divide by y. So this part is actually e, right? So this is now e raised to x by y, e raised to x by y, but still limit is there, right? Limit is there. So what you do now, for since we have x, y, everything, right? So this is what we have. Now for this you take a limit, because the term, this one, this is same as what? E. So what you can do now, limit x tends to infinity, e raised to x by y. For that better you find x by y separately. So for this power you apply the limit, then e raised to that answer, okay? Limit x tends to infinity, x by y you find out. So that is limit x tends to, actually this is the answer you are getting, okay? So limit y tends to infinity means that is x also tending to infinity only, right? So limit x tends to infinity, x by y. What is y value? The substitution x square minus 4x plus 2, x square minus 4x plus 2 divided by 2x minus 1, 2x minus 1. It goes up. So you are getting limit x tends to infinity, x into, in that bracket you take one x outside, 2 minus 1 by x, right? Divided by, take x square outside, 1 minus 4 by x minus 2 by x square. Whenever x tends to infinity, this is how you have to do. X into x is x square cancel. When you apply the limit infinity, 1 by infinity 0, numerator is only 2. Here the second term, third term 0, you are getting 1, so you are getting 2, but this is not the final answer, this is for the power. Power is 2, but here already we have e raised to the power. So your answer is what? E square. Little bit different question, so practice well. Okay, so all other questions you can do very easily. So this one sum you practice well. Look at this question, question number 25. Limit x tends to 0. E raised to x minus e raised to minus x by sin x. It's a very simple one, right? So limit x tends to 0. So denominator we have sin x. Whenever you have e raised to x, we need a minus 1, right? So here minus 1 is not there. Last term is minus e raised to minus x. We need a minus 1, so you put minus 1 plus 1. Value should not be changed. So that is limit x tends to 0. Numerator we give separate limit. So you group these two together. E raised to x minus 1. So next to 2 you take a minus n outside. So e raised to minus x minus 1, right? Divided by sin x, so you give separate limit. Limit x tends to 0, sin x. So numerator also you split into two limits, okay? Split into two limits, and every term you divide by x. Every term you divide by x. So you can understand the reason. Limits theta tends to 0, sin theta by theta is 1, right? Limit the x tends to 0, e raised to x minus 1 by x, right? It is 1. So every term you divide by x. So here you divide by x, here divide by x, denominator you divide by x, and numerator you split into 2. So limit x tends to 0, e raised to x minus 1 by x, minus limit x tends to 0, e raised to minus x minus 1 by x, divided by limit x tends to 0, sin x by x. Both numerator and denominator we are dividing by x. And one thing you remember, the first limit is 1. And these three must be same. Yes, here it is same, so you can write your answer as what? 1. But for the second one, since it is e raised to minus x, I want minus x here. Here also I want minus x. So I'm going to write one more step. This minus, you take it inside. So that minus you can put here, right? So I write here plus limit e raised to minus x minus 1 by minus x. That outside minus is taken here. X tends to 0. I want minus x. Both the sides you change the sign. So x become minus x, 0 become minus 0. It is 0 only, right? So minus x tends to 0. Now all the three are same only, no? Denominator is 1. Limit, trigonometric limit, right? So now it is 1 plus 1 by 1. Leave it. So your answer is what? 2 is your answer, okay? So now let's move on to question number 26. Limit x tends to 0. If you apply the limit directly, you give 0. Power is 0. Any number is 0 is 1. So 1 minus 1 by 0. So it is 0 by 0 form. So limit x tends to 0. Denominator is x. Here we have e raised to ax minus e raised to bx. So you know, for these type questions, we need a minus 1. So minus 1 plus 1. So limit x tends to 0. E raised to ax minus 1, group, first group. Take a minus outside, so e raised to bx minus 1 divided by x. Split into 2 and 2 limits. So the first one is limit x tends to 0. E raised to ax minus 1 by x minus limit x tends to 0. E raised to bx minus 1 by x. But Since we have ax, we want here ax, here also ax. In the second case, it is bx, so I want bx, here also bx. So we have to make some changes. See what changes you have to make here. Listen, in the first one, since we have ax, here I want ax, so denominator you multiply by a, numerator also you have to multiply by a. And x tending to 0, a and x also tending to 0. The second one bx, so I need a b here, denominator multiply by b, numerator also multiply by b. X tending to 0, bx also tending to 0. So see the situation. So now this part, it is 1, right? 1 into a minus here also this part is 1. 1 into b. So your answer is a minus b. Okay, now let's move on to question number 27. Limit x tends to 0. Sin x, if I give 0, 0 by 0, right? X you put 0. So since we have a sin x by x, then it will become 1, right? But we have x cube. Take 1x here, we'll see the remaining. Limit x tends to 0, sin x. X cube is there, I'm taking 1x, I'm grouping with this. So remaining limit x tends to 0, 1 minus cos x by what is left out? X square, because x cube, 1x we have taken here, you know the reason. Limit x theta tends to 0, sin theta by theta is 1, right? So this part is 1 into limit x tends to 0. Use identity 1 minus cos x. What is that? 2 minus is there, no? 1 minus cos x is 2 sin square x by 2. 2 sin square x by 2 by x square. Now they take that 2 outside, so 2 into limit x tends to 0. Square is there, no? So we put the whole square. So you write sin x by 2 by x. If I want to use trigonometric limit, since it is x by 2, I want x by 2 here. So divide by 2 and multiply by 2 in the denominator. X tending to 0, x by 2 also tending to 0, right? So now you know, for this part, limit theta tends to 0, sin theta by theta is 1, right? So you are getting 2 into 1 by 2 the whole square. So that is 2 into 1 square is 1, 2 square is 4, cancel, 1 by 2 is your answer. Okay, now let's move on to the last question in that exercise. Limit x tends to 0, tan x minus sin x by x cube. If I give 0, 0 by 0 only. So limit x tends to 0. Tan x can be written as sin x by cos x minus sin x by x cube, right? So that is limit x tends to 0. Take one sin x outside. What's sin x we have taken out? So what's the remaining? 1 by cos x minus 1 by x cube. That x cube I am splitting like this. Here one x, here one x square. You know the reason, like previous question, right? Now you split into two limits. Limit x tends to 0. Sin x by x, that will be 1. Into limit x tends to 0. Take LCM cos x. 1 minus cos x. That one x square is there. So here the first one, this is 1, right? So 1 into this cos x you take separately. So limit x tends to 0, 1 by cos x. Remaining limit x tends to 0. Numerator 1 minus cos x, like previous question. 1 minus cos x by x square. So that is 1 into, here you can apply the limit. Here you can apply the limit. For x you put 0, cos 0 is 1, so 1 by 1, right? Limit x tends to 0. 1 minus cos x, what is that? 1 minus cos x is 2 sin square x by 2 by what? X square. Take that 2 outside. Here 1 into 1, 1. Take that 2 outside. Limit x tends to 0. The whole square you can write sin x by 2 by x, the whole square. So what you need extra? You just multiply, divide. See? Here, since we have x by 2, I want an x by 2 here. So into 2. Here also x by 2. So now you know this part will be 1, right? Limit theta tends to 0, sin theta by theta is 1. So 2 into 1 by 2 the whole square. So that is 2 into 1 square is 1, 2 square is 4. Cancel, your answer is 1 by 2. Okay. So totally 28 questions, all the 28 questions I taught in 3 videos. Go through the example sums. We'll continue in the next class.